So my name is Sofya Gorelova. I'm a statistician in government now. I'm a civil service statistician. I started my statistical career or analytical career by studying mathematics at university, and then I went on to study financial mathematics at master's level. And then instead of following on the academic route, I went into the civil service and became a statistician, first of the Department of Health. And at first I was based in Leeds, and I was collecting data on things like waiting times and NHS activity we have in each hospital that I rent. Or again, I think you have a little bio about me, but I collected the data on breast implants when the PIP breast implant scandal happened, and looked at how risky they actually are. And then I moved down to London and worked a lot on social care, homelessness, so kind of trying to find the evidence base on things that are very hard to collect and understanding how to get the numbers in the first place, and then including all the issues with the numbers. For example, you cannot collect the number of homeless people because they do not come and say, I'm homeless. So after Department of Health, I moved on to HMRC, where I've been 6 weeks now. And now I'm kind of trying to work out how much it costs to collect tax and to pay out child benefit or tax credits and things like that. So I very much am a statistician to start, and then a civil servant and stuff. I'm very neutral. By law, I have to make sure that the statistics that we publish are neutral and don't particularly play up to one party or another party. So my professional interests come before the minister, for example, or the prime minister, if what they're trying to use the numbers for is not right, or what the party's trying to use for is not right. So it's a very good starting point if you're an academic coming into the civil service. So the next thing I'm going to talk about are surveys, questions and polls. So, for example, the first thing you have to think about is, what are you actually counting when you see a survey, you see the questions? So, for example, if you've got 4 chairs, or 5 heartbeats, or 2 ballot papers, 3 sets of footprints, that could actually represent this family of 5, because the wife is pregnant and you have, the toddler that's being carried and the kids. So all these different things can actually describe the same people and the same opinion. So you have to make sure you know what's being counted. There's a balance between when you set up a survey, and I've set up many surveys, having to ask the question. It's very hard to measure homelessness, for example. So you go and count number of people in shelters, for example, or number of people who say they're homeless when they come to the NHS. But we know it's a proxy. We know it's an estimate from the beginning. So the numbers that we publish are already an estimate. They're not 100% accurate, not 100% representative, but they're better than nothing, and they're much closer to the truth than just a number made up out of it based on someone's opinion. So that's something to remember from the start, is that normally the numbers that you see are an estimate before you even go into significance and confidence intervals and all the rest of it. So that's the kind of the first point to make. So just to go through the definitions, a poll or an opinion poll is just a kind of survey of people's opinions or your vote for the next election. A survey is when you want to know what the whole population is thinking, so you can't go and ask every single person in England or the UK or wherever. So you take a sample of that population, hoping that it represents your whole population, and you ask them that question or a proxy version of that question. And then you have an answer that you know is similar to what the whole population thinks, but not necessarily exactly the same. So again, another example of things that you can go and ask in a survey is, if you want to know about crime levels, I don't know, you look at the crime statistics, but not all crimes are written down. Or if you want to count unemployment, again, people don't register somewhere when they're unemployed officially unless they go and claim benefits. But it's not that every single unemployed person is going to go and claim benefits. So there's that proxy, and you have your survey, which is another estimate on top of your original estimate. So I think my whole section is just going to keep building up on how much of a kind of estimation game it is. You have to be very careful to think a number, it doesn't mean that it's a fact straight away because there's a number attached to it. Yes, so some of the things to think about. What were the exact questions? Do you know what they were asking, so you can work out what kind of proxy it is and how similar it is to the thing they're trying to measure? And are the numbers actually precise and fair? Here's an example. So this article has found that stats show married people are outnumbered in the UK for the first time. So in 1994, there was a percent of single people, 47%. In 2014, that number is 51%. But if you remember what Richard was saying and Robert before said about confidence intervals, if you ask 1,000 people in a survey, your sample of the whole population, your result would actually be plus or minus 3%. So the change there might not be significant at all. In real terms, it might not be change, it might just be that natural variation. And also there's another issue with their picture and their headline. Can anyone sort of point out what that is, what the problem here is? Pardon? There's 3 options, yeah. So they don't say how many married people there were, the percentage of married people, or some single people may be cohabiting, not cohabiting. Are they still single? Are they, So once you know your question, you are in a better place to judge how good the survey actually is and what the numbers really mean. Okay, so here's another example. Here's some questions. Should Polish kids get UK benefits? And are you fed up with Britain's traditions being axed? Well, this is very interesting. This is where your kind of sense checking should come in, and you should stop and think whether the results really reflect things. First of all, why use Polish kids? I mean, is there an attempt to lead the question there? And then 97% is a bit strong for Polish kids that have never done anything to you personally. Most likely you've never been in contact with Polish kids who have been stealing your money behind your back. And again, the same sort of example. Are you fed up? Britain's traditions, which are so great, being axed. Are we talking about dancing around the maypole or Sunday roast, for example? I don't think I'll be 99% fed up with giving up dancing around the maypole. I think there's something more to this question. And the point is you need to know, who did they ask? First of all, how many people? Was it like 10 people? Or 100 people, which isn't a very large size at all. And once you know the number of people, are they representative of the whole population in England or Britain, to say, is this what Britain feels about British values, and what's defined as British values for the people answering the question? These are clearly leading questions. You have to be very careful to see what effect does the questions have on the people answering them.
Sorry for interrupting. You know that, I know that, we all know that, but we don't read the Daily Express. Yeah. That is the point. This is not to make a sensible statement. This is called propaganda.
It is, but some of these numbers, not necessarily here, and it's obvious, but sometimes, like Rob was talking at the start about a mistake is made or big numbers made, or there's a quote in the title that says something like this, and then you read the whole article and actually there's loads of caveats and that's not what it means at all. Like we're talking about diet drinks causing obesity and stroke. But if the title itself, even in peer-reviewed academic, really respectable journals, say something similar to this to make the point, or in any paper, most people won't read to the bottom, and it's kind of still asking the same questions of every number, because it's not always as obvious as this. But if you remember the questions to ask from this, because it's easy here, then you can apply the same rules to things that are not as clear-cut to do the test, I think we'll do an activity, because we've been sat down most of the day. And I think Richard's going to help me out with this. Yeah. If we can split you into 2 groups, if you just want to take half the room and half the room, to make it easier. So if half the room come with me outside, and then half the room stay here, and then we'll give you some instructions for a very basic exercise, and then we'll come back to count the numbers on the counters that are only on the black squares. So you see there's counters and there's numbers on them. You need to add up the numbers that are only on the black squares.
So it's white squares.
Oh,
No, so it's black
I may have,
squares.
yeah, I ripped them up, but just go for the black squares. Yeah. And see what you get, yeah.
And it says if any counter overlaps the boundary, count it if it's mainly on black.
Yeah.
Are we doing that?
Yes, yeah. So decide which tile you think it's on, and then if it.
What about that one?
What do you think? What do you think?
It was partially on 2 black squares, and probably about 50% of the tile is on black, but it's between 2
Wow,
black ones. I don't know
interesting.
if that's...
Okay, so go with
And the
not
numbers that we
including-
were the numbers on the square, does it matter, or just all count as one? Or?
No. So the numbers are the things that you add up.
Okay, sure.
Yeah.
I need to... And the fact that numbers are partial, is that part of the
Yeah,
trick?
just go with whatever it looks like. Yeah. Whatever you think that is. It's not easy actually.
It's not easy, no.
No, it's
There's
not
a few
easy
judgment
at all.
calls in that.
There are a lot of judgment calls in there. So what sort of numbers did everyone get? Just to let you know now, my group counted the numbers on the black squares. This group counted the numbers on the white squares. So shout out some numbers of 26, 16,
I got 38.
38, nice. Okay, so really the point of this task is to show that there's a lot of bias in all of these numbers, first of all. The numbers are not all fully written, so you have to guess whether that's a 2 or 3. There's, yeah. I thought so too. I thought someone's gone wrong here. And then you have to decide whether count is on a white tile or black tile. Sometimes it's very obvious, sometimes it's not so obvious. Actually, the real answer, because they're not all in the middle, none of them are in the middle exactly, if you measure tiny amounts. The answer is that there's 60 overall, 30 on the white, 30 on the black. Now, do you think if we did this again, you'd get a different number? Because if you know the answer, you're going to look for the answer, you're going to alter it. And this is the thing with bias in general. It affects you. Sometimes you don't realize it's affecting you. Because you're counting black, sometimes you'd include things because you're looking for the black squares. You know, you'd add that number in when it shouldn't really be there. So that's just an example of something to watch out for again. Here's another bit of bias. This one's my favorite actually because I'm recently engaged and I'm getting married in May. I see this number a lot. And I mean, if you read somewhere else, sometimes it says 16,000. This is all fairly outrageous to me because I have no savings whatsoever. So you read this article, it says the average price of a wedding is £20,000, 273. The first thing to notice is the very exact 273. Normally that's a dead giveaway that actually there's not much accuracy involved in the calculation. Next thing to ask is what do they mean by average? Is that a median, a mean, or a mode? We'll talk about averages a bit later, but they will be very different. Certainly not a mode is a number that repeats most often. I doubt that the number 20,273 repeats most often and things like that. So you need to work out what average means. It's not as obvious as it might seem. And then who were the respondents? Who are answering these questions? So if you look further, it actually turns out that this is from the Your wedding magazine, which is actually a kind of more pricey of the wedding magazines, and the people who read those magazines are not ones like me who want to spend a kind of small amount of money and just have some sort of party and move on with it. These are the people who really want a really big day in the most perfect hotel venue, whatever. So you might not want to answer that you only want to spend £2,000 when you're reading this magazine all the time and all these nice things seem to cost 10 grand at a time for caterers or whatever. So yeah, who's answering the questions? You should be able to find out what the sample is and the sample size. That could be based on 3 couples. That could be based on 10,000 couples. We don't really know. And finally, who's collecting the data or who commissioned the research? So the research commissioned by the wedding magazine, they make their money off the advertisements, and the advertisements want to sell as much as possible, as the most expensive as possible kind of deals. So they don't want the price to be too low. And then it turned out that the people who actually carried out the survey were a wedding insurance company who quite clearly wanted to be quite a high price. So
it's not a real story.
It's not a real story, no. Thank God for me, because otherwise I'll be in trouble. Oh. So yeah, there you go. Those are the sort of questions. And the importance of the questions and definitions. This one's fairly good. So quite recent, February 2014, 70% of Britons say we must ban new migrants. Again, I feel this is a little bit relevant to me, this presentation. I moved over when I was 9 of my parents. I hope that the people I now live with don't want to ban people like me coming here ever again. I hope I haven't made that bad an impression. Actually, what happened, if you look at the source of the data, based on a YouGov poll, so 21% of people said stop immigration completely, 49% said reduce it. And not by, it doesn't say maybe by 1%. It doesn't say how reduce it by the whole thing. So all they've done is added one to the other and thought, okay, 70%. So how they actually defined the thing. And often, if you have a survey that has a lot of different categories, it's quite easy to group them together when you really shouldn't be grouping them together. Okay, it's time for another exercise. If I get the, again, if we go outside, but this time, if we go outside together, because we have a big map that we need to lay out. Okay. So, if someone just takes some counters, anyone, doesn't really matter. And if you take them and sprinkle them anywhere you want on this map, just go wherever. Yeah.
All of them?
Yeah. Why not? Cool. Okay, that's probably a good amount. Right, so I can clearly spot that this area here is quite busy. Now these dots represent incidences of disease around the world. Here is particularly clustered. Why would you think that is? All right. Apart from that.
It's in the middle, and if you're trying to throw something, it's going to go to the middle. I mean.
All right. Okay. It's in the middle. Why is there a cluster here? Go in the geography and what could be the sort of reasons for it. I'll have a more realistic example in a second.
Very cold up there.
Yeah, I think it's cool.
Yeah, there we go. Maybe.
It's mainly at sea, and like there's contagion on cruise ships.
Scurvy.
Yep, scurvy, there we go, yep, definitely.
Atlantis has some disease problems, maybe?
Yeah.
No,
It's
that's
good place, yeah. Again, you can see that I can move that frisbee, whatever that is, onto a different area, and we can find other reasons like that's a mountainous range, there's less hospitals around, less doctors around, so they can't treat you. So it's just showing we all know that these were cast down at random, but actually they have clustered, they're not uniformly, in every single square of the map. So it's important to remember that it's a natural phenomenon for things to cluster. So if suddenly you have a street, and I've definitely read these stories before, there's a street, they've built a telephone pole or whatever, they've said, suddenly there's 10 cases of cancer in our village, it means it must be this telephone pole, it must be something else that's been introduced in our particular village, it must be the water supply, anything. Whereas actually, it's normal to have these clusters in places. So if you see something that seems crazy at first, actually you look more into it, that's just natural variation, because you can't have exactly one case per village across the whole world, because that's not how real world works. It's a bit more complicated. That looked like a fairly unrealistic example, but actually that's pretty much how things happen in real life. So another example that Daniel Kahneman uses in this book called Thinking Fast and Slow, which is a very good book. He's a behavioral economist. Daniel Kahneman, Thinking Fast and Slow. He's the kind of, him and Amos Tversky were the pioneers of behavioral economics, and they were psychologists, and they looked at human behavior quite a bit. So an example that he used is kidney cancer in America. So they got some data and they looked at it and they realized, they not Daniel, someone looked at some data and realized that the places where kidney cancer prevalence is the highest in America are the states that are sparsely populated, Republican states, near the Bible Belt, fairly rural, and this is where the highest incidences occurs. Why do you think that might be? Yeah, that's what I'm saying. Yeah. And again, if you look at the same data, they also found that the lowest incidences of kidney cancer also occurred in the same rural, sparsely populated Midwest American states, Bible Belt, whatever. And again, you can think of reasons like they live in a country, there might be more kind of active lifestyles, they may farm or do something a bit along those lines that might be healthy in that way. But actually the point is the key to this is that they're sparsely populated. So for example, because it's a proportion and prevalence is a proportion of population that has cancer or whatever, because there's less people, you need to have less people who have cancer before it's quite a high proportion. So if you just imagine a bag and some marbles in the bag, if you have a bag of marbles and you pull out, and they're just black and white and that's it, and if you pull marbles out at random, you'll much quicker get 4 marbles in a row that are either all black or either all white than if, for example, you're pulling out 7 marbles of a bag, and then to get out 7 that are the same color will actually take you much longer amount of time. The difference is huge between the kind of how long you're going to be sat there pulling marbles before you get 7 the same. And that's just how it works with the smaller, sparsely populated rural states. It's just much easier to have the either not much cancer or a lot of cancer because they're smaller, there's not many people in it. Whereas if you go to New York or something, suddenly it will take you forever to get the same results. So you have to, when you're comparing things, make sure you're not just comparing regions, the region size, you're comparing the people in it, and it's what you're counting that's your sample. It's just something, again, to bear in mind. Oh God, there's... So moving on to statistical significance, we've mentioned it a lot. The problem with statistical significance is that if you're just speaking in English, significant means important, whereas in statistics, when we say something is significant, all we're saying is that it's likely that your result is not due to chance alone. Which is not the same. Just because it's not due to chance alone doesn't mean it's important in any way. There's actually a lot of studies, a lot of research goes on that finds results that are tiny, not important in any way, but they're significant. And a lot of PhD theses like that, you have to find something. And it's fairly easy to find something significant, but not necessarily important to anyone. So yeah, there's the cluster of cancer cases. It's very hard to tell residents in a particular area that have a lot of something that it's not due to, I don't know, a big corporation or bad water supply or telephone poles or whatever. There's just bad luck. But again, and it's not a very good story to write, this village had a lot of bad luck today. You have to write something, But maybe that is actually the cause. Oh, go on.
I was thinking about the clusters. The Ebola outbreaks are clustered in a certain area, and that's significant.
Yes.
I believe.
Yes, yeah, it is, because we don't have them here.
Yeah, but I'm just wondering how that sits with that random nature of the...
It's finding the line where a cluster is due to natural variation, and then a cluster is due because there's an actual cause here, and for Ebola, it's things like hygiene and not enough medical supplies and Yeah, so it's very difficult to find that line. It's actually, we'll get to correlation and causation in a second, but it's very easy to find a correlation, something where you have the same pattern, you think it might affect each other, but actually it doesn't. It's much, much harder to prove causation. And that's where, again, at the start of the day, we're talking a lot about randomized controlled trials and how complicated they are. You need a control in every experiment that doesn't get the experiment and someone that does. You need to blind them so no one knows whether it's a sugar pill or whatever. And it goes, I worked in the clinical trials medical unit in Leeds, and there was they were testing kind of robotics for surgery. No, I don't quite remember what it was anymore. I was there for a couple of weeks. But I remember they actually blinded all the participants, and they kind of put them to sleep, but not in a general anesthetic dangerous way. So they didn't know whether they had the surgery. They didn't know whether it was done by a robotic arm or whether it was done by a surgeon. So you have to blind people to that same extent to see if the results are actually biased or unbiased, whether it's a cluster or not. So it's very hard to prove cause and effect. Yeah. Confidence intervals we've mentioned a lot. Again, all the confidence interval is if you have your sample of the population and you're trying to estimate what the whole population thinks, the confidence interval is a measure of how accurate your result is. So how accurately your estimate is actually representative of the whole population. It says, as an example, sample size, 1,000 people, it will be plus minus 3%, which is why, going back to the single people, married people example, they could have actually been between 44% and 50%, and here between 48 and 54. So they could have been the same percentage of single people a decade ago to now, and it's just the natural variation. The confidence intervals actually cross over, and if they overlap, that's quite a crude but quick way of knowing whether they are significant or not. If the confidence intervals overlap, then you know that it's probably not significant. However, there's the thing about subgroups. So you might have 1,000 people who answer your questionnaire, but actually if you split them by men and women, and then you go into age bands, and then you go into ethnicity or something like that, then suddenly your sample size gets a lot smaller. So just because you see the whole sample size is fairly big, actually look at what the number being reported is. Is it something like, I don't know, 18 to 25-year-olds are single? Actually, that's cut down your sample size dramatically, and especially if you say, 18-year-old women or whatever, suddenly there's probably about 10 people in that sample, if that, and that's not a very large sample at all. The final example on surveys and significance. So this is a league table. League tables in particular are not very, very good. These are the top 10 streets with the highest numbers of burglary cases. So you can see Fairfield Drive and Bury's got 10, but actually Primrose Hill, which is 10th, has got 8. Because this is a snapshot and you don't actually, this might be just a really bad week for a particular drive. Again, it might just be natural variation. It might be that Bury is not the dodgiest street ever, just based on this league table. Things move up and down very rapidly just from natural variation, just from certain things happening. So watch out for league tables. And again, all of these are equal. Why are they listed in that order? They can be in any order at all. And the actual whole number of incidents is very large, so I think it's very uniform between all the kind of streets, as opposed to saying one is particularly bad.